Is there any way to prove the multiverse theory and how it works? Thanks to the newly developed James Webb Space Telescope, there is. Enabled by the level of its sophistication, James Webb Telescope will spend a significant amount of time putting the late Professor Stephen Hawking's multiverse theory to the test. It's too bad he died before the James Webb Space Telescope was launched into space. Stephen Hawking worked on this idea to the point of his death. This idea, referred to as the multiverse, proposes that there is another planet containing an exact duplicate of you. It is just mind-blowing. Welcome, and in today's video, we will have a look at how the James Webb Space Telescope has finally proven Stephen Hawking's multiverse theory. The late scientist had some suggestions to share about the topic at hand. According to the multiverse idea, our universe, which contains tens of billions of light years worth of galaxies and an infinite number of stars, may not be the only one that exists. Instead, a world might emerge quite similar to the one we live in now. This wacky theory proposes that there could be an infinite number of universes. Each universe has its own physical rules, its collection of galaxies and stars, and perhaps even its advanced civilization. According to the multiverse, our universe may be one of many others that are considerably larger and include a greater variety of things than our own. This is to mean if there is a multiverse, there are several versions of oneself, sometimes known as doppelgangers. This is a very unsettling concept. Just imagine, there is another version of you holding onto that smartphone the same way you are holding it at the same time. But according to this genius Stephen Hawking, in reality that is actually happening. There are an unlimited number of universes, and there are an endless number of occurrences co-occurring, all at the same time, despite the massive distances. Over 3.5 years after Stephen Hawking's death in 2018, the James Webb Space Telescope was launched into orbit. Scientists have come across several challenges with this space telescope. The original launch date of 2007 was moved to 2021 due to various complications. 344 single-point failures, often known as items that are required to be done for the mission to be successful, were discovered by independent reviewers. In addition, the cost was $10 billion, roughly 10 times the amount first proposed. This powerful space telescope could only begin its mission after it had been launched into orbit, assembled and tested for many months. The large 6.5-meter mirror of the telescope, which had to be folded up for launch, will enable the telescope to look into the atmospheres of the planets that are not part of our solar system. Additionally, the telescope can see the birth of a new star and planetary systems through enormous dust clouds. The telescope was sent into orbit on an Ariane 5 rocket at the spaceport in French Guiana on the 25th of December last year. After the rocket has lifted off into the air, it will detach and begin to unfurl. According to NASA, the solar panels of the telescope were exposed to the atmosphere for the first time just 30 minutes after the launch. According to NASA, infrared light can also travel through gas and dust, even though these two things appear opaque. This telescope, in contrast to the Hubble telescope, is limited to just being able to detect light in the ultraviolet and near-infrared spectrums. For the instruments on board to function correctly, the temperature must be maintained at or below -370 degrees Fahrenheit. To prevent the many components of the telescope from overheating, a large sunshield is placed in front of it. There is a lot of competition among astronomers to use the JWST because of its enormous potential. The Space Telescope Science Institute, which is in charge of both the Hubble and the James Webb Space Telescope, had asked astronomers how they would use James Webb's 6,000 hours of observation time. They have already completed their projects, and we're eager to hear what they say about their experiences. Because it has enough fuel to endure for almost 20 years, the James Webb Space Telescope will have a lot of time to figure out some of the greatest mysteries in the cosmos. Inflation theory is perhaps the most well-known illustration of the multiverse notion in physics and philosophy. The theory attempts to explain the origin of our universe. The term inflation theory refers to a hypothesis speculating about an event that may have occurred within a few hundred millionths of a second of the universe's beginnings. In that little time, the universe experienced a period of enormous expansion, which resulted in the development of its size by several orders of magnitude. It has been speculated that around 14 billion billion years ago, the expansion of our universe came to an end. It has been speculated that around 14 billion years ago, the expansion of our universe came to an end. However, since it is not feasible to simultaneously bring inflation under control everywhere, it will likely continue to rise in specific locations, even after it has been brought under control in other areas. This indicates that even while inflation has stopped in our region of the universe, it may still be occurring in the different areas of the cosmos. Inflation exists as a limitless and eternal sea that never ends. It is filled with many distinct worlds, each with the potential to become independent from larger ones. According to this model of eternal inflation, it is conceivable that each universe would have its own set of physical laws, particle stock, the configuration of forces, and values for fundamental constants. This may be why certain aspects of our universe, like the cosmological constant and dark matter, are so difficult to explain using just the basic principles of physics. A significant number of researchers in the field of science think that the most compelling evidence points to the presence of life, more specifically intelligent life. This is how it seems to them, because that is how they see it. In a study titled A Smooth Exit from Eternal Inflation, which Hawking co-authored by Catholic University of Leuven physicist Thomas Hertog, the two authors presented an alternative approach to explain how the universe first came to being. Even though it was his last piece of writing, the essay examined one of his earliest concepts. If the JWST successfully establishes that the multiverse is accurate, the researchers who contributed to its development will likely be considered for the Nobel Prize. However, as the Nobel Prize can't be awarded after a person has passed away, Stephen Hawking will not be eligible for any honorary honors. The light that was there in the early stages of the universe will be able to be collected and reflected by this telescope. The JWST telescope will be able to study the light emitted by the universe's earliest stars and galaxies, which are estimated to be around 13.8 billion years old. The JWST can use infrared light to locate objects in space. Using this telescope, you can see heavenly bodies such as stars, nebulae, and planets that are either too far away or too faint for the human eye to detect. Since the JWST has been relocated to a location around 1 million miles from Earth, whether or not it's time to test Stephen Hawking's most intriguing theory, the idea of a multiverse is debatable. This one is different from the others due to the most current approach released by the professor, which is what makes it such. It would seem that the existence of long-lived stars, a sufficient quantity of carbon, sufficient light for photosynthesis, and the stability of complicated nuclear power are all necessary for life to exist on Earth. But if you take a stab in the dark and choose a universe at random, you probably won't discover these things there. These positive characteristics of our reality are because the multiverse contains other parallel universes. We are closely checking this one since it can support multi-part life. Using techniques that can identify ripples in space-time generated by the early expansion of the universe after the Big Bang, it is conceivable to hunt for traces of other galaxies using those methods. These ripples were caused by the early expansion of the cosmos following the Big Bang. Primordial gravitational waves are the term used to describe these disturbances. If the new hypothesis is correct, then it indicates that our universe may have been just one of many that emerged due to the Big Bang. Additionally, there may have been gravitational waves at the beginning that traveled along with the universe's expansion. To put it another way, this new approach has not yet been shown to be effective. We need further evidence and a deeper comprehension of string theory to accomplish this goal. Scientists have come and gone, but Stephen Hawking still stands out even after his death. They say most theories that try to define the cosmos can only be established in philosophy and physics. Most of them, in reality, are not actually true. The James Webb Telescope has seemed to help solve this mystery and could provide evidence to the debate that has been between scientists for years now. Some scientists have concurred with Stephen Hawking, while a lot of others have rejected his theory, regarding it to be null and void, or rather mere imagination. The solution rests on the James Webb Space Telescope. Researchers have been scouring the physical world in search of proof that the multiverse is real. Do you think the James Webb Space Telescope will bring a solution? Share your thoughts in the comment section below. If you enjoyed the video, don't forget to like, subscribe, and share with your friends. Thanks and goodbye.